I'm Dr. Roy. I'll be teaching ENPM640 Rehab Robotics. Welcome. So I'm a practicing rehab roboticist. You'll understand more about what that means as we get into the course. How do humans learn a new task? They learn a task by what is needed to learn a task. What is at the heart of, if you want to learn a new task, say you want to learn how to swing in golf and you have never done it, what is needed for you to learn that activity? The most important thing is repetition, but by who? Machine or human? So to learn a new task or an existing task that has been diminished due to an injury such as stroke, you need master repetitive practice. In other words, if a machine practices for you without giving any opportunity to you to practice that task, will you learn? You won't, as soon as the machine is taken away. All right? The other thing is mass repetitive, means you have to not only practice on your own, but you need to practice that task over and over and over again, hundreds of times, thousands of times. Again, what is suitable for something like that? Robots. But the problem is, robots mostly will give you that practice, but on their terms. They won't let you practice. Most robots work like that, right? So the challenge in this course is, how do we design controllers for machines that provide walking therapy to address these problems, while those machines have to be very cleverly designed. Patients are allowed to practice on their own, and the machines only help when patients need it, but not otherwise. All right? That is the crux of this course. This is where rehab robotics is different than other robots, which can be pre-programmed, whether it's path planning or anything else. So now we come to some robotic solutions that you'll see here. This is a robot, lower limb robot known as the Locomat, manufactured by a company called Hokoma in Switzerland. We have a robot at Rehab Institute here in Maryland itself. There's another patient undergoing training in the Locomat. These are both stroke patients. And this is another one called the Rewalk. I'll fast forward. This is also a powered exoskeleton. This is manufactured by an Israeli company. Now, the question is, how do we go from these primitive entities such as canes and braces to these sophisticated machines that have sensors, different types of sensors, different control systems at times? These are very sophisticated machines. So how do you go from this to that while taking into account the walking disabilities caused by neural injuries or brain injuries? You have to not only design machines that are effective, but what is a prerequisite, even a precursor to even effectiveness? What do you think about when you take a drug? Yes, it has to be effective, but prior to that, it's got to be safe. If the drug kills you, then there is no question of effectiveness, right? So the key idea behind rehab robotics, and I'm going to use the word RX robotics, the overarching goals are safety and efficacy. All right? Questions so far? That is what this course is about. How do we design machines like that? What are the factors we have to take into account? Okay?